Hello, I'm Patty Simpson with Simpson Math. In this video, we're going to learn about exponential functions. So an exponential function is just a function in the form of f of x equals b to the x, where this b we call the base, and the the x, our variable, our input, is in the exponential position. And that base, where b, the base, is a positive constant. Is a positive constant. So b has to be a positive number, just some number is all that means, that constant. Other than 1, because 1 raised to any power is kind of boring. It just is 1 over and over again. So other than 1, and x is any real number. In other words, we can input any number we want to in for x. And when we've talked about domain in the past, what that means is that my domain is all real numbers. So when we talk about the domain of an exponential function, our domain for these exponential functions, because x can be any real number, that means that our domain is going to be x such that x is an element of the real numbers, or in interval notation, both of these mean the same thing, they just mean x can be any number. So that's the form that an exponential function takes. So let me give you just a couple of examples of exponential functions. Here's an example where I just have some constant, say 2, raised to the x power. That's an example of a exponential function. Here's another example. I'm going to take, how about 1/2 raised to the x power. I just have some constant that's a positive constant, not 1, being raised to that power. Now, the exponential function, when we talk about the exponential function, it looks like this, where I have e raised to the x power. And this e right here is a number, kind of like, we all know that irrational number pi. We're familiar with pi. Well, e is also an irrational number. E shows up especially in finance, when we try to continuously compound our interest, and it shows up in other places as well. But e is just a number that's approximately equal to 2.718281828 45, 90, 45, and it just goes on and on and on. Now, for our purposes, if we can just remember that it's a 2.7-ish, then we'll be in good shape. So it's close to 3, but not quite. So 2.7 is good enough. And we'll also need to know that when we square that e, it's approximately 7.29. So if you take that 2.7 times 2.7, you get 7.29. And this is just some number. It's just some number being raised to the x power. So therefore, that is the exponential function. A couple of reminders about exponents. So remember that when we do 1 over x, we could also write that as an exponent with x to the -1. So in this case, if I put in -1 for x, if I take an input, a -1 in there for x, this is the same as saying 1 over that number, 1 over 2. So just a reminder that -1 exponent is the same as 1 over your base there. Then another reminder is if I have some number raised to the zero power, any non-zero number raised to the zero power is just equal to 1. So in that case, if I'm inputting in here 0 into my function, 2 to the 0 power, well, that's a non-zero number, so raised to the 0 power is just equal to 1. So just a few reminders there as we begin to graph these. Those reminders will be important as we graph these functions. So in the next video, let me show you one more thing. In this case, if I have the function, or if I just put -2 raised to some number, like, we'll just say x, my base there is still 2. This is still my base. It's the 2 that's being raised to the number, and then it's being multiplied by -1. I could rewrite that as -1 times 2 to the x. That is different, however, than -2 raised to the x. Now my base is -2. Now we said with our exponential functions that our base must be a positive number. So in this case, my base is a positive number. In this case, my base is not a positive number. So this would not be, I cannot say equals y and then make that an exponential function because the base is not a positive constant. So just some reminders about exponents and what they look like. In the next video, we're going to graph this exponential function of 2 to the x. Math Made Simple at Simpson Math. Thanks for watching.